This video is about finding the kg fluid of a vessel, but that's main thing is about finding the free surface moment of a oil tank, and we will see what kind of moment of inertia we need to work out to get the FSM and then the kg fluid. So let's see the past paper from Chief Mates. An undivided DB tank of length 18 meter has following half ordinates of waterline at equal intervals measured from forward bulkhead 2.0, 2.5, 3.9, 5.2, 6.7, 8, 10.1 meters respectively. Fuel oil of RD.9 is loaded to a sounding of 0.8 meter in the tank. Assume tank to be wall-sided. Determine the kg fluid in the final condition if initial displacement was 20,000 tons and initial kg 10 meters. So we have been given the surface ordinates for the area. I mean, for the water plane, half ordinates. That means half water plane area has been given of the tank. We can find the full area using the Simpson's rule. Here, a very important assumption is to be made that is given here. Assume tank to be a wall-sided. That's very important assumption because it allows us to assume that the sides of the tank are parallel and the liquid surface area of the tank is constant as over the depth. So the liquid surface area not changing because tank is wall-sided and its sides are parallel. This is important assumption here. So this will allow us that the kg of this tank can be taken as half of the sounding 0.8 meter because it's wall-sided. So no curvature and all. So let's see how we proceed with such questions. Okay, we have here this diagram. It's a half water plane, rather, because it's not water, it's an oil tank, but they call it water line. From forward to aft, ordinates are marked. Here 2.5, this is forward, and this is the aft. We have 1, 2, 3, 4, 5, 6, 7 ordinates. So Simpson's rule number 1 can be used. There will be 6 equal intervals. 6 equal intervals means each interval is 18 upon 6, 3 meter, because 18 meter is the length of the tank. Now for finding the kg fluid, we need free surface moment, and free surface moment we know is moment of inertia of the tank about its center line multiplied by density of the liquid in the tank. So we need to find transverse moment of inertia about the center line of the tank, because the free surface moment takes place when the ship is rolling and there is transverse shift of the liquid inside the tank to one side. So that means we need transverse moment of inertia, which is about the center line of the tank. This is the center line here. So we need moment of inertia about this center line. And of course, because our ordinates, which are half breadths, they are perpendicular to the axis. So we will need to use a phi cube function for the Simpson's rule. Okay, first we will find the area. Okay, so this is, I have divided in two parts. This box is about the area, and this box will be for moment of inertia. So for area, we just write down half ordinates in a tabulated manner here from forward to aft. From forward to aft, all the half ordinates. Then Simpson's multiplier 1424241 and the area function. So multiply the ordinates with the Simpson's multiplier, each ordinate by its corresponding multiplier, and we get the area function. So take the sum of the products, call it sigma 1 summation 1 96.1. Then total area of this total surface area of the liquid will be h upon 3 into summation 1, which is for the Simpson rule number 1, h upon 3 into sum of the products multiply by 2, because we are dealing with half ordinates. So in order to get the full liquid surface area, I must multiply by 2. So it comes to be like this: h upon 3, h is 3. So 3 upon 3 into sum of the products for the area function 96.1 multiplied by 2. I get 192.2 square meter. This is the total liquid surface area of the tank. Now, since the tank is wall-sided, so we assume that the surface area remains constant throughout the depth of the tank, no change. So I can multiply this surface area by the depth of the oil, which is the sounding in the tank, and that will give me the volume of oil in the tank. So 192.2 is the surface area and 0.8 meter is the sounding. So area multiplied by the depth, I get 153.76 meter cube. This is the volume of oil in the tank. And what will be the mass of oil or weight of oil loaded in tons? So volume of oil multiplied by density of oil. 153.76 multiplied by, they have given RD is 0.9. So as you know that RD, if you take the density in tons per cubic meter, it will come out to be same like RD only. So just multiply by 0.9 because we are dealing in tons. So we get the weight of oil loaded as 138.384 tons. This is the oil loaded. Now for the moment of inertia, go back to the other table now. Okay, this is my other table. So as you know, because the ordinates are perpendicular to the axis. Axis is the center line of the tank passing through the centroid of the tank along the length of the tank. And the ordinates are half breadth, so they are perpendicular to each other. So when ordinates are perpendicular to the axis, then we need to Simpsonize the cube of the ordinates, because here if we're doing by integration method, our formula for integration is y cube dot dx upon 3. So y cube dot dx, that is calculated by Simpson's rule here, that upon 3 is taken out of the integral, and later on we divide by 3. So I write the half ordinates as from forward to aft. Take the cube of every ordinate. So cube of 2, cube of 2.5, cube of 3.9, like that. We may find the cube of every half ordinate. And I write the y cube function here. This is y cube. Now the cube of the ordinates, they are put through Simpson's rule. So Simpson's multiplier 1424241. Okay, Simpson's multiplier will be multiplied with the y cube of the ordinate. And we will get the moment of inertia function, moment of inertia about the center line. The product will be moment of inertia function. Here the sum of the product for moment of inertia 4431.397. I call that sigma 2 summation 2 is 4431.397. This is the sum of the product for moment of inertia, and apply the Simpson's rule to get the transverse, to find the transverse moment of inertia IT about the center line of the tank. So Simpson's rule number 1, h by 3 into sum of the products of moment of inertia function sigma 2, and as I explained, must be divided by 3 for moment of inertia and multiply by 2 because we have half breadths. So if we have half breadths, we need to multiply by 2 to get the moment of inertia of the full tank. Okay, so H is 3 by 3, and sum of the products is 4431.397 moment of inertia function. Divide by 3 and multiply by 2 for the full water plane area. So it's 2954.265 meters raised to the power 4. This is the moment of inertia of the tank about its center line. Free surface moment is moment of inertia of the tank about the center line multiplied by density of the liquid. So it's 2954.265 and density of the liquid is 0.9 tons per cubic meter. I get FSM 2658.838 ton meter. Now FSC is FSM upon final displacement. Remember to use the final displacement, not the initial displacement is 20,000. Initial displacement is 20,000, but we have loaded oil equal to 130. This is 138.384 tons of oil has been loaded. So I have to get the final displacement, which is 20,000 plus the 138.38 tons of oil, and the final displacement will become 20,138.38 tons. This is the final displacement after adding the fuel oil loaded. So I get the free surface correction as 0.132 meters. And then we also need to find the final kg by vertical moments. So we'll make the table for final kg. We write the word initial, then kg, and then vertical moments. Okay, initial displacement 20,000, initial kg 10 meters, multiply, and we write here 200,000 is the vertical moment, initial. Then load 138.38 tons of oil, and the kg of the oil 0.4 meter, half of the sounding. The depth of the oil or the sounding is 0.8 meters and tank is wall sided, so I can safely take the kg of the oil as half of the sounding. So 0.8 and half of the 0.8 is 0.4. Vertical moment will be 55.354. So multiply 138.38 with 0.4. We got 55.354. Now final displacement is add the 20,138.38 here and add the vertical moments. So 2055.354. Okay, final kg is final vertical moment upon final displacement. Vertical moments are here 2055.354, final displacement 20,138.38, and kg solid is 9.934. So must add free surface correction to it because they are asking kg fluid, and I found the free surface 0.132 meters. Add and I get kg fluid. 10.066 meters. So that is the answer, 10.066 meters. So here the important thing was to know how to find the free surface moment. What kind of with using Simpson's rule, because we need to know if you need to find the moment of inertia which is in a transverse or the longitudinal. So because the free surface correction is a part of transverse stability, as the ship is heels, when the ship heels, the oil in the tank will flow to the lower side. So this is called transverse shift. So that's why we need to find the transverse moment of inertia, which is always about the center line axis of the tank. And the ordinates are vertical, perpendicular to the axis. Here, this is the center line axis, and these are the ordinates which are perpendicular. So when the ordinates are perpendicular to the center line axis and we need to find moment of inertia, so we must do the y cube function. Cube of all the ordinates, they must be Simpsonized. And then in the end, don't forget to divide uh, the sum of the products of this moment of inertia function by 3. Because as I explained, the formula is y cube dot dx upon 3 for moment of inertia, transfer moment of inertia. So y cube dot dx is calculated using Simpson's rule here. So in the end, that division by 3 remains to be done. Okay, that's all, and thank you very much. If